Hi class, this week we are going to be starting a new chapter on factoring, and we have three different pieces to this factoring chapter that we are going to cover over the next 2 weeks. And obviously we are winding down here till the official end of the school year. So for those of you that are continuing to work, really just the next 2 weeks are the last 2 weeks that any new work will be assigned. So we'll be finishing up this chapter on factoring by next Friday, and after that you will not have any new work that is assigned to you. So the first factoring process we're going to learn about is greatest common factor. And in this case, you have a little bit of a review. So last week we talked about multiplying these polynomials together. And when we did that, we were distributing and we would add the exponents together. So in this case, you would have 3a squared plus 7a. In the second one, as you distribute this negative 2m, you would get negative 2m to the third. Negative 2 times 6 is negative 12, and you have m to the second. And negative 2 times negative 1 is positive 2, and you want to bring that m over in your final answer. In the third one here, you have 5, you have x to the second, y. Then when you multiply 5 and negative 2, you get negative 10. Keep your x, add your y's together, you get y to the second. That's a process that we learned last week. This week we're going to be learning about factoring, which essentially is the reverse of multiplying here. We are going to be learning about the process of separating a polynomial back into a product. So we're going to take something like 3a squared plus 7a and factor it back into what you were given in the beginning. We're going to pull that a out and write what is left over in the parentheses. If something cannot be factored, those polynomials are considered to be prime, meaning that they cannot be factored any further. So you'll notice here in the box it states there will be several ways to factor. The approach we will take depends on the polynomial. Today we will start by using the greatest common factor. Now this skill of greatest common factor is something that you learned back in elementary school when you talked about a GCF. It is the largest number, hence greatest, that is divisible by each one of these terms. So if we look at number 1, you have the number 3 and the number 12. So it obviously helps immensely if you know your times tables well, because in this case, hopefully you would know that 3 and 12 are both divisible by 3. So I'm going to write a 3 on the outside of this parenthesis. Now, if you have been using the graphing calculator, there is a little trick that you can use on that I would have showed you in the classroom. But for these, I'm trying to keep them simple so you can look and know automatically this is divisible by 3. Now you will notice one term has an x, the other one does not. So you cannot factor out a variable unless both terms have that variable in common. So I'm going to now start a parenthesis. In order to figure out what is left in that parenthesis, I am going to divide both of these terms by that GCF that I factored out. And as we're dividing, remember the rule was to divide the coefficients. So 3 divided by 3 is 1. And you don't have any exponents to worry about, so you're going to bring the x along in your answer. Then you will divide 12 by 3, and that would give you 4. Now, you'll see in bold it says check your answers by redistributing. So one way that you can check these solutions is you can distribute this 3 back to each term. Well, if I took 3 times 1x, I would get 3x. If I took 3 times 4, I would get 12. That's the exact expression that you started with here in number 1, and that's what we are looking for in each one of these. We are essentially breaking these polynomials down into their two factors and back into a product. Now that redistributing part, I don't really need you to write that every time. That's why I'm erasing it here, but it's definitely a good way to check your answer. Okay, now if you scroll down or look at the second page here, you will notice that there are some rules, and I think these are actually good to go over before we go any further. So number 1 says, look at the coefficients first, okay? Those are the numbers. What we mean by that is we want to find the GCF of the coefficients, if there is one. Find that highest number that those two numbers are divisible by. Now, the next part deals with the variables, and you notice it says a variable must be common to all terms. So all of the terms have to have the letter X, or they all have to have the letter Y, and so on, in order to factor it out. If they have a variable in common, then you will take the one with the smallest exponent. So think of it as the opposite of what you're finding. For the greatest common factor, we take the smallest exponent out of each one of these terms. Then your last step, once you figure out that GCF, is to divide. Divide all the terms by the GCF to get the remainder in parentheses. So these are really the 4 rules you're following here with this GCF concept. Okay, so as I come back here and I look at number 3, I'm going to work down this first column. I see the numbers 5 and 30. Well, 5 is divisible by both 5 and 30. They have the letter X and Y. Well, those are not the same, so the only thing we can factor out here is the number 5. So I'm going to divide everything by that number. That will leave me with 1x and 6y. Okay. Number 5, same idea. 6 and 27. They are both divisible by 3. Oops, sorry about that. They have no letter in common, so I will divide both of these terms by 3. 6 divided by 3 is 2a squared. 27 divided by 3 is 9. In number 7, you have the numbers 21 and 3. They are both divisible by 3, and they both share the letter D. So this letter D should be factored out as well, and that is what you will be dividing by. Now remember your rules for division. So we divide 21 by 3, you will get 7, and you subtract the exponents. So C will remain, but D minus D leaves us without any D's in that part of the expression. Then you divide 3 by 3, that will give you 1, and 1D minus 1D, they will cancel out, so you have no D written in your final part of the expression. Okay, moving on to number 9, 15 and 30. They are both divisible by 5. If you look at the letters, they have the letter A and the letter B in common. So you take out the smallest amount. So I can take out 1A and I can factor out 1B. As I divide both of these terms by 5AB, 15 divided by 5 is 3. 2 A's minus 1A leaves us with 1A, and the B's cancel. 30 divided by 5 is 6, and you'll notice in the second term the A's and B's will both cancel, leaving us with this as our final answer. Number 11, there are only letters, but you notice in the terms they both share the letter A. So we will divide by A. That leaves me with B. And even though these A's cancel out, you still need to have a number here to hold this place value. So A divided by A, yes, the A's cancel, but you still need to keep a 1 there as the coefficient. Okay, moving on to the back page, same idea, but a little bit more complicated in terms of the variables. So 18 and 48. The highest number that is divisible by both of these is 6. And you look, they do have an A, a B, and a C. So take out the smallest of each. So we can take out one A, one B, and two C's. That is what you're going to divide each one of these terms by. So as you are dividing, 18 divided by 6 is 3. And subtract the exponents. You're going to just be left with one A here in this case. 48 divided by 6 is 8. Again, as you subtract your A's and B's, they will cancel. But 3 minus 2 will leave us with 1 C in this final answer. Now in number 15, this doesn't happen very frequently when I am asking you about this topic, but if you look at 5 and 13, 5 and 13 are both prime numbers. They do not share any common factor. So if you get in a situation that cannot be factored, you will write the word prime. I will tell you, this is the only prime expression on this handout, so that should be the only one that you write the word prime for. Last but not least, number 17, 6, 14, and 10. You may have more than one number. Well, 6, 14, and 10 are all divisible by 2. And you notice they all share the letter y, so we take out the smallest amount, which is y to the second. That is what you will divide by to determine what's left over. So 6 divided by 2 is 3. Subtract your exponents, you get y to the second. 14 divided by 2 is 7, y. And 10 divided by 2 is 5, and the y's will cancel, so you will just have a 5 as your last term. What I would ask you to do in the rest of this assignment is go through and answer the even column. So go through with what we've just talked about and practice using the GCF in each one of these expressions. So from 2 down through 18, and once you have completed those questions, then I would ask you to submit this assignment. Good luck, and as always, if you have questions, please reach out for help.